I'm Spencer Kimball. I'm the CEO and one of the co-founders of Cockroach Labs. Let's see. Great. So I'm actually going to talk today just a little bit. I guess this is a continuation of the commercial about global applications and the sort of challenges around building them and what we've done in order to support that. So fundamentally, what is the cloud today? Right? I like to think of it fairly simply as it's just a bunch of servers. They're mostly somebody else's servers, and increasingly a bunch of services. In fact, most companies these days, when they launch, they don't even think about software anymore. It's really about a cloud-first application that's being served to their users. But the cloud is a collection of servers, and sometimes those are on-premise. Sometimes they're in one of the big cloud vendors. Sometimes they're in some sort of regional telecom or one of the private data center companies. And they're increasingly global. So this is one very interesting distinction in today's world. A company, a startup that has 5 people just out of the gate, has access to the same kind of data center resources that Google had back in the aughts. So it's an exciting time to be building things. The big problem, and I think it's why we're all here today, is that a lot of these technologies don't work well together. Networking, can you discover the services that are up? Can you connect through the different layers of abstractions to the pieces of your architecture that you need to talk to? Security is a big issue here, so you've got encryption in flight and at rest, key management systems. You've even got things that are doing runtime encryption at the actual level of the chipsets in some of the new Intel architectures. Deployment is a huge one. Everyone knows that Kubernetes has kind of changed the game. It's bringing sort of the Borg technology from Google out into the wider world. The problem is that Kubernetes itself doesn't work very well across clouds and across multiple data centers. And there's, I think some of the talks here are going to address some of the solutions that are trying to bridge some of those gaps. And fundamentally, we believe that data is a pretty unsolved problem in this environment. And it's what we've spent the last 4.5 years now working to solve. It's really the critical element. I guess a fully stateless global service might just be a mortgage calculator, right? You can't do too much more than that. So you have to solve data, and it's a difficult problem. Some of the companies have already been mentioned, but there's an exciting list of speakers, and a couple that I'd call out. There's Upbound, Bassam Tabbara there, that is working on a system called Crossplane, which is trying to bridge some of this deployment gap. There's Heptio and VMware. There's OpenShift from Red Hat. There's the Cloud Native Computing Foundation, of course, that are pushing just a huge host of technologies that work on solving these problems. So some exciting technologies and companies. And of course, a lot of the practitioners, as Jim mentioned, that are going to be here talking about how they put those pieces together and actually solve big problems for their customers. So Nate already covered some of this, and I'm sure everyone knows the answer now, but what's the single biggest problem if you're trying to build a global service? It's fundamentally physics, right? It's the speed of light. In fact, the speed of light is your theoretical maximum. In practice, things are a lot worse than that. Networks are getting faster for your cell phone, which is how most people are accessing services these days. Still going to be somewhere between 50 and 100 milliseconds, even with 4G. That number will go down, especially as 5G rolls out. But then you've got regional backbones to get out into the fiber from your cell provider, and you've got potentially intercontinental links if you're not lucky enough to live next to where a particular service you're using is deployed. So, as an example, and this is probably something like 95% of the services that are running out there on the cloud. There's a single data center somewhere, one availability zone. So in this case, it's a data center in Richmond. In this particular diagram, we have all of the cities in the United States with over 100,000 people represented. And the latency legend at the bottom goes from 0 to 250 milliseconds. So if you went all the way to 250 milliseconds, you'd be in the red. All the way across the states, we have pretty good latencies here. So it's about 70 milliseconds over to the West Coast to get to Richmond. We're getting kind of close to that 100 millisecond rule that Nate mentioned. You can see that from Los Angeles, you're still a little bit into the yellow spectrum here. However, when you zoom out, things look considerably less rosy. Most of the world is pretty underserved with this single data center in Virginia hosting a service. So a user, for example, from Sydney has to hop across an intercontinental link to get to the United States, and then that's 70 milliseconds to get across to Richmond. So that's 220 milliseconds, so far over the human threshold for noticing what feels instantaneous, which means that they're going to have a worse user experience fundamentally. There's also been a pretty big trust breakdown globally. Part of it is some of the big tech information monopolies and some of the abuses that have gone on there. It's fundamentally, reflected, I think, in the proliferation of data sovereignty regulations. I think in 2015, there were 109 countries that had introduced data sovereignty laws of some sort. But fundamentally, it's also about the user experience. I mean, it's one thing to have regulations, but your users, whether you're a SaaS company and your users are other companies, or they're actually individual human beings out there, they do care about their data privacy. They have preferences. They'd like their data to be domiciled and processed in their legal jurisdiction. That's going to make them feel more comfortable. And you, as a vendor with a service, if you're competing with a local competitor that doesn't have that stipulation that your data is going to be shipped, for example, to Virginia in order to be processed and then shipped back, that's going to be sort of a marginal benefit for that competitor that you have, and it'll be harder to keep that customer. So user experience is big, and that's about, does the user experience feel fast or does it feel antique? And it's about, do I have some assurance that my data is being respected and my privacy is being respected? And I think it bears mentioning, a lot of companies out there that are providing these services, even their engineers don't always feel very comfortable with what they're doing with the data. It's a very difficult problem, and fundamentally, we're limited by the technologies. So how do you build a global service? I think the big thing to realize, from that nice global map that we looked at, is that you really do need to eliminate geographic latencies. You're never going to solve these problems. And that means that you have to put the app tier and the data next to the customer. If all you did was put the data next to the customer, I mean, that would be something. You'd be domiciling it next to them. But if you have to ship the data over to Virginia from Australia, you're going to lose any kind of latency improvements that you could have by storing the data next to the customer. And of course, you're going to violate the idea that their data is being processed in their local legal jurisdiction. Now, stateless application logic, it's very easy to see how you can replicate your microservices and put them wherever your customers are. The fundamentally difficult problem is, what do you do about state, so the data that you're storing? And you want to keep that consistent. I think the traditional solution to dealing with global applications has been to rely on eventual consistency. And I'm sure there's many people in the room that have gone down that path and then found out that the complexity of those applications grows over time to the point where it becomes very difficult to continue to build and to keep things in a sane state, and to keep the user experience from degrading because things that you just updated aren't available, and it seems that the data is being lost, and then all of a sudden you've got multiple instances of something because the users created it multiple times. Fundamentally, what we've realized is that most data actually has a location attached to it. It's not just a primary key and potentially a timestamp when it was created. There's usually a location that matters. It might be the location of the customer or the company. But with that location, you can fundamentally decide how you want to partition the data. As a very sort of simple high-level example, you might decide that you want your European users to have their data replicated only in the EU, and similarly for US users and Australian users, as an example. So what we're talking about is geodistributing our data, and that's hard. And when you have a hard problem, well, you need the right tools. What is another problem, so this is not the speed of light anymore, another problem that's inescapable when you're building any service. Everything fails, right? It's going to be the DNS or the network. Someone takes a backhoe through the fiber optic cable, or your nodes get rescheduled, VMs go down, the cloud has a problem that's systemic. These things fail. So the biggest thing that we can do with geodistribution is realize that there's a huge number of opportunities inherent in it. And the first is resilience. So as an example here, we've got 3 data centers on the east coast of the US, and we have a user coming from Nashville. In this particular Cockroach cluster, we have 3 replication sites. Cockroach uses what's called consensus georeplication to store the data. Many distributed databases in this day and age are embracing this model. But what it means is that you just need a majority of the replication sites to agree, and then data becomes committed and durable. So Atlanta wants to write the data. It sends a request to write the data to the other 2 replication sites, to Durham and to Richmond. Durham is going to be the fastest, only 13.5 milliseconds. When it returns, your data is committed. If Durham goes away, we still have complete business continuity because Richmond can return. Business continuity is maintained here. We have a slightly higher latency, but it's not too high. Things work well in this model. When we zoom out now, we can see that the legend's not to 250 milliseconds, it's to 100 milliseconds now. This is the threshold we really want to care about. This is the threshold for an instantaneous user experience. We can see that these 3 East Coast data centers aren't necessarily serving the West Coast very well. So latency is the next thing that we can really fundamentally address with geodistribution. In many ways, it's instructive to actually take a step back and realize that the traditional monolithic database where all the processing in the database is essentially one node or a couple, or a group of tightly coupled nodes. It's sort of like the Oracle rack model. It's a very fast system. Everything's close. There's no geographic latency, but it lives in one place. So it's the sort of equivalent of that Durham data center or the Richmond data center. And someone from California going there, it doesn't matter if the database is fast. The end-to-end latency is necessarily going to be 70 milliseconds at least. In this particular model, what we have is instead of putting the 3 data centers in the Cockroach cluster all on the East Coast, we're spreading them across the United States. So now you can see that the West Coast users actually are nice and green because they get to hop to Salt Lake City. Central US users go to Fort Worth and East Coast to Charlotte. And in this particular case, we've actually located the data centers in a very interesting configuration. It turns out the United States has 3 power grids. There's a Texas power grid, of course they have their own, and then there's an East Coast power grid and a West Coast power grid. So this actually eliminates the sort of systemic risk around US power grids. If we have a user from Los Angeles, they're going to be able to connect to Salt Lake City. Now, it's important in this particular configuration of Cockroach to realize that a Los Angeles user's data isn't just stored in Salt Lake City. It's also stored in Fort Worth and in Charlotte. But there's a preference. These things are partitioned so that there's a preference that a Los Angeles user or any West Coast user's data is going to have what we call a leaseholder inside the Salt Lake City data center, which means that those accesses to the data for West Coast users are always going to be fast for reads. Writes still have to go to Fort Worth before they're committed, but the reads are very fast and local. So this gives you great performance in a cluster. And similarly, an Omaha user is going to hit Fort Worth, and a Philadelphia user is going to hit Charlotte. So in both of those 2 cases, Central and East Coast, their leaseholder preferences are partitioned to Fort Worth and to Charlotte, respectively. So it's a good system. Zoom out, we've still got this horrible problem. There's a lot of red on this map. So how do we extend this to really serve global customers? This is about partitioning and localization. In other words, attaching a location to data. So in this case, we've got 5 regions around the world that we're going to serve. These are just sort of chosen at random. We probably would be interested in full coverage, but we've got North America, South America, EU, China, and Australia. So interesting places. And what we're doing is we're using 3 data centers in each of those regions to do consensus georeplication for those users specifically. So if we zoom into Europe, there's a lot of countries in Europe with more than 100,000 people. Roughly what we have here is 3 replication sites for all EU data. So every piece of EU data is replicated in each of these locations. But we're going to split up the European countries and cities into Eastern Europe, Northwestern Europe, and Southern Europe. So a customer that's coming from Warsaw would be considered Eastern European. Their leaseholder preferences would be in Berlin. They have a very fast experience with their requests coming into Berlin and going back to Warsaw. If it goes away, that Warsaw user is probably going to hit London. And their data is going to be between there and Barcelona and will always be correct as well. So we have all of those properties, but now we're talking about just the partition of EU users, and we can see how much better they're served than having to hop over to the United States. Similarly for Australia, not as many cities with more than 100,000 people, but if you're coming from Adelaide, you'd hit Melbourne in this particular case. But there's a big deployment challenge that remains here. So we have 15 data centers around the country. That means 15 Kubernetes clusters. I mean, a fairly complex set of networking and security-related issues. And this is just a glimpse of the complexity. And our SRE team with Cockroach Cloud has been hammering away at these problems for the last year. But we've got these multiple Kubernetes clusters, global DNS in order to make sure those users hit the right data center that's closest to them. regional load balancing. So you're talking about 15 different load balancers, of course, at these data centers. You've got elastic scaling to worry about both with the database and then your application tier. And one thing to realize is that if a startup wants to use this, just the sheer number of VMs and load balancers and services that need to be running and maintained creates an initial cost footprint that's, I think would be a bit of sticker shock even for a bigger company. So that you have to figure out how to do fractional cost structures here. There's inevitably more complexity at the application level. You have to partition. You have to decide how you want to partition and the nomenclature. Are these US East, US Central, US West, or do we have a more fine-grained structure? So there's complexity that creeps up. And fundamentally, this demands a multi-cloud solution. No cloud vendor out there, from Google to Amazon to Microsoft, these are the big three, and now there's Alibaba Cloud, but none of them are everywhere where your customers are. And we hear this again and again. You have to mix clouds, and you can't even rely just on the public cloud vendors. You have to go to private clouds. When we squint and look at the future feels like everything will be distributed systems. And that inevitably means that you're going to have additional application complexity. And that can be managed, but it has to be taken into consideration. It's not just single region, it's multi-region now, and that means that you need different tools. Certainly database is one of them. And fundamentally, you have to embrace a world where you're going to use hybrid and multi-cloud approach. So that's why we're throwing this conference, hosting it. And I'm extremely proud and pleased to be a part of it. And this, as Jim said, it's about more than Cockroach Labs. It's about more than any of the companies here. It's about a growing realization that we have to solve this problem to fundamentally move the state-of-the-art forward and essentially provide better user experiences for customers. So thank you all for coming, and enjoy the show.